Hello, I'm Isaac. I'm a tutor at the Economic Center at ASU. This is going to be a discussion of a topic of budget curves. So we're also going to cover the axes in this video as well. We have a good Y and a good X when you look at a budget. When you go to the store, we're assuming you're only purchasing two goods for the simplified economic example. And these goods could be anything. In my last example, I used junk food and healthy food, so I'll do that again. Junk food. All right. So when you go to the store, you have essentially a budget for purchasing two goods. We're going to assume that junk food and healthy food are just, you go to the store, you either have two units and it's junk food or healthy food. And you have some money and you're going to be able to purchase either one of those goods. And so what really is going on here is these have prices, you have your budget, and you're going to buy quantities of them. So the graph, so we're going to look at the budget that kind of works through this. So I labeled this budget 1, B1, and really what this represents is an equation, which is money, or your budget, equals the price of Y. I'm just going to put P and then the little subscript Y times how much you purchase of Y, which I'm just going to label Y, plus the price of X times how much I'm going to purchase of X. So X, of course, is healthy food, and Y, of course, is junk food. So this is just the equation for this. And remember, when you go to the store, you don't get to pick the prices. You don't get to pick how you have a certain amount of money you're going to have. So money you have, your budget is constant, the price of Y is constant, and the price of X is constant. So just think of them, you can assign them arbitrary numbers. They don't really, they're kind of relative prices. So what we're going to look at here is what's really going on here. So when you go to the store, you can purchase a combination of goods. Maybe you purchase 5 of Y and 4 of X, or 5 junk food, 4 healthy food. And you can purchase 6 Y and 3 X. So we can actually calculate how much money we have. If we have the price of either X or Y, we can actually determine all three of these units. So we're just going to do an example of that. I'm just going to erase this so I can label. Let's say I can purchase right here, I can purchase 10X, and right here I can purchase 20Y. All right. So, and let's say I'm giving you the price of X originally. Let's say price of X, just as a given, this may happen in your class. Price of X equals $2. So, but if I'm given the price of X, I can calculate the rest of them. So first I'm just going to look at if I purchase all X, how much money am I spending? Because price Y, this quantity will be 0 if I do that. So I'll just set this equal. So M at right here at this point where I'm purchasing 0Y and 10X, I'm having price of Y times 0, so I'm purchasing 0Y, plus $2, which is given. $2 is my price of X times how much I'm purchasing of X, which was 10. So essentially, if I simplify that, I'm having $20 is my budget, my M. So now that I know my budget, I'm able to determine the price of Y. So right here at 20, we also have 0X. So we can do this again. We get a price of Y times 20 Y I'm purchasing, and doesn't matter what the price of X is. I could have the $2. Doesn't really matter because I'm purchasing 0X. Yes, so I do know my budget right now, which is 20. So now I can divide both sides by 20 since this was going to go to 0. I'll get the price of Y equals $1. So now that I know the relative prices, I can solve for Y or X and get this graph either way. So I could just do an example, right? So now if I want, so really if you're looking at like a traditional graph, you kind of solve for Y. I mean, Y would be an arbitrary labeling, but we can just because we like to solve for the Y-axis usually, we'll solve for the junk food. Say this junk food equals this much of X, just so we can understand the slope and how everything works in the budget curve. Okay, so now we're going to plug in the values and see if we can solve for y and kind of get like a traditional looking graph where you have y equals, what's this, x, y equals x plus an intercept type of thing with a coefficient on the x. So we're going to do, what we already have from previous is that $20, which is the money, I mean the budget, $20 equals $1 times how much y we consume plus $2 times how much x we consume. So what I'm going to do is I'm going to subtract 2 times x from both sides. Just as a, well, $2 times x, because we're going to actually have to cancel out these units so we have actual right units. But I'm going to subtract that from both sides. Now I have $20 minus 2 times x equals $1 times y. And I can divide all sides by 1. If you're taking some algebra class, you should know that when you divide by units, the units cancel. So I should get the units, and of course 20 divided by 1 is just 20. 2 divided by 1 is just 2. 20 minus, oops, not dollars, we just canceled the units. 20 times 2x equals y. So now we have kind of a traditional linear graph that kind of maps to this budget curve. So that's the general idea of budget. We can also just look at the fact that, as one final note, that what can increase your budget? There's only 3 things. So if we would assume in this fundamentals course is that if we have a budget 2, it looks like this. Make this look a little nicer. That we consume both more y and more x, and let's just say by the same amount. So we could say we consume like relative amounts, 22y, and now we can consume 11x. So they relatively increase by the same amount. We know that the prices would stay the same if I did the calculation, but this is an example of the income increasing. If only one of the axes changed, like this, we can still purchase the same amount of x, but for some reason we can purchase more y now. So that'd be an example of y decreasing in price. Now I want to emphasize the fact that it's decreasing in price because we know our budget didn't change, but we can consume more y. So that really emphasizes the fact that we know our budget didn't change because we can consume the same amount of x if we purchased all x. But when it comes to y, we can purchase more y with the same amount of money. So if you're thinking about it, I go to the store, I can purchase, if I spent all my money on junk food, now I can buy 22 compared to 20. That must means that I have the same amount of money, I still have like $20, I can purchase more y now. So that really is to emphasize the fact that y decreased in price when you can purchase more of it because our money didn't change because x stayed the same. So that can happen the opposite way, of course, where y stays the same and x increases how much you can purchase, and that represents a decrease in the price of x. I hope this is a good overview for you, and if you have any questions about any topics covered in here, you can consult your professor, ask if there's some change of terminology. Also, you can come to the Economics Tutoring Center. Have a good one.